what is the basic definition of free surface? Like, okay, what is a free surface? So shall we call it is like a topmost layer of liquid exposed to air or atmosphere, air or atmosphere, and what is the thickness of it will be few molecular range. Here what happen, rather than showing it very thin, let it be few molecular range. Few, what is the molecular range? 10 to power of minus 10 meters. So this will be of order 5 into 10 to power of minus 10, 6 into 10 to power of minus 10. So like that what happen, the thickness. So this particular free surface is what we are going to learn. We are not bothered inside the liquid. The fluid statics, fluid dynamics, we consider more about the inside the liquid. Now only the free surface we are going to learn. So no, here is what free surface. So this will be molecular range. Thickness is what? Few molecular range. So how you define topmost layer of liquid? Topmost layer of liquid exposed to atmosphere and is of thickness of few molecular range. Okay, this is about the free surface. So now let's define two types of molecules are there. So molecular forces are of two types we can categorize here. Cohesive, sorry. Cohesive forces, adhesive forces. What do you mean by cohesive forces? It's a force of attraction between molecules of same kind. Force of attraction between molecules of same kind. So this is the again force of attraction between molecules of different kind. Okay, like this what will happen, we will define the two types of molecular forces which we are going to bring into the picture often, cohesive force and adhesive forces here. So now the force of attraction between water molecules, I'll call them as cohesive. The force of attraction between the molecules of water and molecules of air, they're of different kinds. So that will become adhesive force. Or the force of attraction between the glass, okay, there's a glass container we'll take, between the glass molecule and water molecule will be adhesive. Between two water molecules will be cohesive. So based on this resultant of these two forces will happen, the free surface will try to align. Especially we are bothered about this region. We are not bothered inside the liquid. Inside the liquid only cohesive forces will come. At this particular point you check it, both adhesive as well as cohesive force will dominate. No? There'll be force of interaction between molecules of water, force of interaction between the glass and the water molecule, force of interaction between the water and air. So this particular boundary, what happened, becomes very important for us. How the liquid will behave here, how the shape will be. To study that, what happened, we are taking help of the surface tension concept here. Now, I say that molecule. So in here, okay, we'll take the next thing. There's a very simple ideas are there. The initial theoretical ideas are very important. Once you get on that, it'll be very easy for you to understand. So there's a free surface. The free surface, what happened? Let me make a thing. So let me show it by a thick line. Huh? One thick line, I'm showing it. So what we have molecules here. Not needed. This is later on. I'll bring it here. come for this. So here what happens, shall we go for molecules? There should be plenty to make understand things. I'm taking like this here. Now, what are these? These are the molecules, that one. Later on, I'll shade it. Now, time will not be there. So just that molecule, I'll show by yellow color. Let me focus on the molecules which are at free surface. So the force of interaction between them. Here, let's look at this molecule. So what it look? It will experience a force like this. It's an attractive force, no? So what do that arrow indicates? Attractive force. Let me show that color also. Attractive, will agree that arrows, they will try to pull each other. So what is the nature of this cohesive force? It will try to bring the molecules nearer to each other. This is what they're trying to pull each other. So look at this particular molecule which is there inside the liquid. What is the net force on it? Will be zero. And what is the state of it? It is in equilibrium. Will agree? That's simple idea. So there's a molecule, I'll call it as say some X. We'll give some number. This one. Look at that molecule X. What is the net force on it? Will be zero. So if I show that only molecule, so what are the this is the way what happened. We have to show forces on the molecule here. So this is the molecule X. So what is the net force on it? Will be zero. In the books, what happened? The same thing they have shown it in this way. Getting so nothing wrong. Both are same. So what do this arrow? What is this arrow indicates? What do you mean by this arrow? Cohesive force. So what is the net force on the molecule X? Will be zero. So I'll write it here. The net force on molecule X is zero and is in equilibrium. Like that, we can also go for this molecule. We can go for this molecule. Like this, if you pick up any molecule, no, the net force on it will be zero only. Yeah. Okay, let's come for the molecules which are there on the free surface. I'm interested in the molecules. So let me give number 1, 2, 3, 4, 5, 6. Now look at molecule 1. It is also acted upon by the forces, no? Look at the molecule. It's also acted upon by forces. So the 3 what happen will exert a force on it. So the 3 will be acting like this. Even 2 also will exert a force. Even 5, even 6, even 4, even other molecules also. So I'm not okay. Even there'll be a force like this. Even there'll be a force. Even it'll be like this. Okay, we'll show it. No problem. Books, what happen? You have only theoretical discussion. Diagrams are not there. That's why you find that imagination very difficult. I'm giving enough diagrams. Are they able to understand now? So look at, let's show the force acting. So shall we put like this? I think if you want, you can magnify in your mobile, see things clearly. Look at that arrow. Huh? So look at that molecule 1. So what this molecule 5, 6, 7, 8, 9, 10, even 11 also will exert force. I'm not showing it. So look at the molecule 1. These molecules which are there, all these molecules, what they are trying to do, they're trying to pull it down, no, the molecule 1. So you as if you imagine like there's a person 1, there is arms, these two are his arms, and what about this, these are all legs. So what all other persons are doing, they are holding its lower part of the body, or they are holding their body and they're trying to pull down. Then why this molecule 1 doesn't comes down? It's a simple logical question. This chapter is over. Finish. I'm telling this one, this chapter is over. Some of you might have studied surface tension. What is the surface tension now? Okay, force acting, tangential force acting on the surface layer. Finish over. That's what the book is telling. The pictorial representation is little bit difficult. This is like a, just to make students understand, I brought this method. Okay, now what all these molecules are trying to do? They're trying to pull the molecule 1. Then why doesn't it is coming down? Who is supporting it? The molecules 2 and 3. Somehow they are holding him. So slightly what happened, this will be inclined like this, slightly. It may not be exactly horizontal because it's horizontal. Who will balance this? So slightly it will be. So actually if you go and analyze, no, so this will be the situation. This is 1, 2. I'll draw a better diagram. Huh? So slightly I'm showing it. I need more space. No? Look at it. Exactly 5 is below it. 6 here. 8, 10, 11. Okay, now this was the number 1, 2, 3. So slightly this force will be like this. Is it possible now? Now one can be in equilibrium. Yes. The 2 and 3 with the help of support of 2 and 3 what happened? Somehow the molecule 1 what happened? It's retaining its position. 5, 6. This is 8, 4, 7, 11, 9, 10. Look at this one now. Is it possible now? Component of these two forces can balance? Yes, definitely no. So you look at this particular thing, this particular molecule, what happened? Here you one you can see the layer here. Shall I say there is it one happy? No, no. Continuously what happened? 4, 5, 6, 7, 8, 9, 10, 11. They're trying to pull it down. With the help of 2 and 3, it is somehow it is retaining its position. The same thing happens for 3 also. The same thing happens for 3. What happened will be pulled by what? 4, 5, 6, 7, 8. Here some 13 you can put it, or say 12. Then 11, 10, or all this will be trying to pull. So 3 also the same thing. So all these molecules will be trying to pull it down with the help of this molecule and this molecule, the 3 will retain position. So that is the situation of every molecule. there's a section of every molecule. So if you look at that one, so here what is one? So how do one will be? Is it one happy? Just okay. Is it happy? No, it cannot happy. So one will be struggling a lot. Somehow what happened is struggling a lot to retain its position. So what is the? I think now we have. What about five? Five will be very happy. Any reason? Because net force on them will be zero. I'm putting this particular thing. I think this particular symbol shows that they're in trouble. No. So these things they are very happy. Tell me, like, who is struggling?
Upper layer.
The upper layer. So the struggling is nothing but open. They are somehow. No, that is what I'll tell you that one. So don't use logic here. 1, 2, 3. Okay, the numbers what we did. 4, 5, 6. See, what I'm drawing diagram, no, don't think that molecules will smile just to make students to make a guess of situation. Means the molecule 1, 2, 3, what happened? They are struggling a lot to retain their position. They're not that in comfortable position. So they are putting their own effort. Even high balls also I'm showing. Yeah, look at that one. So they're struggling a lot, this one. So what are molecules 1, 2, 3? They are on the free surface. The same thing happens for that. So now if you go and check it, the resultant of these two forces will balance this particular thing. See, now what do you think? One should come down, but you look at the liquid, free surface will be there, no? And the molecule which are there on free surface will be there only. Then what happens? The resultant of these two forces will balance the resultant of all these forces. And definitely what happened, two and the interaction between 1 and 2 should be more, no, compared to interaction between 1 and 7 or other things. So they should exert more force on each other. They should exert more force on each other. Some extra, shall I put some extra? I'm trying to finish off this chapter, or say what 1 and 2 they will tell to each other. Okay, now let's try our level best. Let's support each other. Let's support each other. So they will exert extra force than between 1, 4. So what is force of impact between 1, 4? No, more than that, what happened will be there 1, 2. Then only what happened, these two forces should balance the resultant of these two forces should balance the resultant of all these forces along vertical direction. Along x-axis, no problem. It's about vertical down. So constantly all these are trying to pull this. The same situation happens for 3 also. The 3 what pen will be tried to pull down by all these molecules, but the adjacent molecules will support it. So they should exert some extra force to retain. Okay, now this we will show it in a very beautiful way. Let me save it first. This diagram, the last diagram is what will really reflect a lot of things. Huh? Just do notice, I'm going to show some forces. What are this? These are forces here. So now shall we put it some extra force here should be there. I should take this also. F plus delta F. So I okay this. Somebody please mute it. Okay, no. Here we have to show so that extra force here, that one. Here what happened? The force will be same arrows. I think some other color arrows will show it. F plus delta F. I'll make it so that I can, yeah, right here. F plus delta F and show it a little bit thick arrows. And inside the liquid, actually, I should not show it. I should not show it. What does it mean? Inside what happened? What is the net force? Net force is 0. I'm not bothered. That extra force is what? It's coming only on the surface. That extra force is what will come only on the surface. F force will be there everywhere. F force will be there everywhere. So in the books, what happened? That's what they just show, like, because to make students to think that there is some extra force is acting. That extra force per unit length will become surface tension. Here what happened? There is no necessity because here F, net force 0. Sir, here also F 0. But this is some extra force is coming. What force of interaction that acts here compared to that will be more here. The reason for that, there's a condition. Are able to understand the methodology here? Sir, here it was some sort of like this. See, what is the state of this? This will be constant. This will try to move down. This will be oscillating. In fact, practically, this will be oscillating. So we are not going for that extreme level, higher level of physics. So just I brought some logical diagrams here. But what is the one? All the molecules here, almost all the molecules in this liquid, they'll be oscillating about their mean position. Fine. So we are not discussing all that particular thing. So just have a idea that one. So some extra force will happen. The molecules on the surface, they should exert on each other so that they can retain their position. This is the basic idea. Please mute it. Somebody like in spite of telling also, unmuting it. Okay, fine. So there's no necessity to show that forces here. Because what is the net force here? Net force on this molecule will be 0. So no necessity of that extra force will come. So this is what free surface. Huh? Now call this is what is this? This is the free surface. So will you see on the free surface some additional forces acting? Yes. And how do that force will act? Tangential to surface. Look at this surface. How the force is acting tangential. Look at the force surface here. Let's assume flat tangential. So how this cohesive force is acting, shall we say tangential to the surface? Tangential to the surface. So this tangential cohesive force per unit length is what we call surface tension. This tangential force per unit length tangential cohesive force per unit length is what we call that as surface tension. So how we define surface tension? The definition, I'll bring it. The tangential cohesive force per unit length is defined as surface tension. So here I'll write it like tangential force per unit length. So what is the unit for this? Newton per meter. So what is the strict condition? It will be tangential to surface. Surface tension, is it a vector? Yes, it is a vector because force is a vector, no? So surface tension is a vector quantity. It's not a scalar, it's a vector quantity. Surface tension is not a force. Huh? It's a quantity we are defining, force per unit length. Able to understand. So this is very important. A student must have this imagination. I don't know why books have missed these diagrams, because that is what develop a even this diagram also not there. I think am I right? Some of you have studied in school. Some of you are studied in school, or might have referred many good books. We don't have diagrams here. I don't know why the books are avoiding the diagram, or why teachers are avoiding the diagram, because the explanation is needed. Why that extra force will come. That's the basic idea. And it will be tangential. What will be the surface, flat, curved, everything. This particular force which is acting, no. So this will be the surface here. This is the free surface. So what are 1, 2, 3? I should call molecules 1, 2, 3. 1, comma 2 and 3 are on free surface. Okay, and so how is the free surface? So we can assume it to be like this, or this will be. And what about all other molecules? These are molecules which are there inside the liquid. So what is the net force on them? Will be 0. So we are not bothered about inside the liquid. So all our discussion is the surface layer of a liquid, the two free surface layer of a liquid. So where do surface tension we see? Inside the liquid or on the surface? On the surface. That's what we see, surface tension on the surface here. So now here of doubts, any liquid layer comes. So put effort on the surface layer of a liquid here. Okay, there's one definition. Now you can ask straight away one good question. Sir, what is the proof? Okay, you've drawn some good diagrams, everything. What is the proof for that? Net force on molecules.
Sir,
Net force is 0 on molecules. Yeah.
sir, in the previous diagram, sir, with the faces, you drew one diagram, sir. Sir, there the particles 1, 2, 3 should be at the same position in the same horizontal position, sir.
You should use your brain power. They are oscillating, I told you, no, the liquids. Huh?
Okay, sir.
Is it possible molecules of liquid at rest? You know chemistry. Why don't you bring your knowledge, what you learned? Molecules will be at rest. Huh? Anybody? Uh, Molecular chemistry got over or not? Molecules will never be at rest, no? Fine.
Okay, sir.
Some scientific way has to be taught. Huh? At this stage, scientific things have to be brought into the mind. Huh? Okay, now this is about, okay, finally there is some extra force is acting between the molecules on the surface layer. That extra force per unit length is what we'll call surface tension. So now straight away you can ask like, sir, like what is the proof? There should be proof, no? We can't just like no, okay, through the diagrams. So we can't just impress a student. So for that purpose, so what we do is like, we'll take a frame. This is a wire frame like this. So for this, what I do is like,